Hi everyone, welcome back to Martin Tutorials Math Questions. I want to apologize for the long break. Unfortunately, I was very sick. I cannot say I'm 100% now, but hopefully I'm good enough to do my YouTube. The pain is under control. Anyway, I appreciate all your patience. I always appreciate my viewers and subscribers very much. This is today's question. We have two walls that connect at 90 degrees. I'm going to put a barrier, let's say a thin wall that's exactly 10 meters long, that touches both the walls, and I'm going to do it from directly above. There's my diagram. These two walls stretch a long way, let's say 50 or 60 or 70 meters, long enough to touch this wall. And this thin wall is exactly 10 meters long. There's many places where we can put it that it remains exactly 10 meters long. The question is find the location to maximize the area, because the two walls and the 10 meter long thin wall forms a 90-degree triangle. Where exactly along these walls? And I made up the variables. M is the distance from this corner to where the thin wall touches this wall, and P is the distance from the corner to where the thin wall touches this wall here. Solve for what M and P to maximize the area of this triangle. You see, I always like to make problems that fit real life. Instead of just saying what's X or Y, let's pretend we're in construction and the people want a triangular room with this barrier but want to maximize area. See, we're solving a real life problem. So to begin with, we're going to make an equation where the subject is what we want to maximize, and that's the area of this triangle. It's a 90-degree triangle, so area is half times base times height. With the variables I chose, the letters I chose, is half times P times M. Area is half, well, here I wrote half MP. And I rewrote MP. Half MP is maximized when MP is maximized. So I'm going to work with MP instead because it's a little bit easier. And I just chose this notation that A in a bracket is MP, whereas the real area is half MP. So I just put that in a bracket so I don't get confused. Okay, now what often happens with calculus, we have more than one variable, and we need to get rid of one. I have to find a way to link them. So if I go back to this diagram, no matter how we position that 10-meter barrier, we always have a 90-degree triangle where the hypotenuse is 10 meters. So we can use our friend Pythagoras, m squared plus p squared equals 10 squared, no matter what. There's m squared plus p squared equals 10 squared, or equals 100. And now we're going to isolate m or p. Just by random, I chose the m. So m squared is 100 minus p squared. So m is the root of 100 minus p squared. If I root the left, I root the right. And instead of writing a root sign, I wrote to the power of a half. It means the same thing, but for calculus, that will be easier to work with. Now it's the derivative. Now I substitute in rather. What I called A in bracket is MP. I'm going to substitute in for M. Instead of M, I'm going to have this bracket to the half. I substituted in for half, and the P I rewrote. And now it's derivative time. What I called A bracket, which is for MP, there's A bracket is MP. Now we do the derivative. The left derivatives, we bring the half down, times this bracket, the minus a half, times the derivative of the inside, minus p squared derivative is minus 2p. So that's the left derivative times the right, plus right derivative. Derivative of t is 1, times left. I just rewrite that left without changing anything. What I like to do, this is just my way, I always put a little marker to show there to there is left derivative, there to there is right, here to here is right derivative, and there to there is left. So that if I made a mistake, I can always go back and check myself and what I meant, so I don't get confused. That's what I meant for the left derivative. It'll be easier to check myself. And as always, if you're doing a course, do it the way your professor or instructor told you. With so many people watching, unfortunately, it's difficult for me to comply with every course. So I always say, do it the way your instructor told you. And now that I've done the derivative, we simplify. Minus 2 times a half is minus 1. P times P is P squared. And I just rewrote that bracket, 100 minus P squared, all to the minus a half, plus, and 1 times this bracket, I don't need to write that 1 anymore, times 100 minus P squared, all to the half. You see, I'm still sick. I'm a little bit out of breath, but I can do it. I'll manage anyway. Now to simplify, there are many ways. I just chose to switch sides because it's a little bit easier with a positive on the left. There are many ways of doing it. So this 100 minus P squared, the half I wrote on the left, and this minus I rewrote on the right. Now I took out a common factor of 100 minus P squared to the minus a half. The reason is because this left no longer has an exponent. See, when we multiply the exponents, 1 minus a half is a half. So if I take this out, we left by this bracket to the 1. You see? And if we take this bracket out from the right, we just left with a minus P squared. So we've got this bracket times 100 minus P squared minus P squared. And there's many ways of simplifying. This bracket, the minus a half, I can write it underneath as 100 minus P squared to the plus a half as a denominator. So to the minus a half as a numerator, it's like to the half as a denominator. And we left with 100 minus P squared is minus 2P squared. This is our derivative. To find that maximum value, we set it equal to 0. A fraction equals 0 when the numerator is 0. So there's 100 minus 2P squared. We're going to set it to 0, which I do over there. Now there's many ways to simplify. Another person might divide through by 2. I happen to bring this minus 2P squared to the other side of the equal side. We both correct. I think they're equally correct. Now to simplify, divide each side by 2. 50 equals P squared. So P is the root of 50, which is the root of 25 times 2. And 25 in a root sign is like saying 5 outside the root sign. So P equals 5 root 2. Now that we have P, let's solve for M. We were told earlier that M squared plus P squared is 100. So M squared plus root 50 squared equals 100. So M squared plus 50 is 100. We already said that P squared is 50. M squared is 100 minus 50, which equals 50. So M is root 50. And as we said earlier, root 50 is the same as saying 5 root 2. So P and M have the same value. So if we go back to the original diagram, M is 5 root 2 or root 50, as we said earlier. And if I plug into a calculator, it's 7.07 as a decimal, correct to 2 decimal points. The same thing with P. 5 root 2 equals root 50, which is 7.07 to 2 decimal points. They're all correct. I always do it based on how the question's asked. Did the question say, tell us the answer with root signs, or tell it to us in decimals correct to this many decimal points? This question did not specify, so based on that, all of them are correct. So P is any one of, I beg your pardon, M is any one of these answers. Let's say 5 root 2. P is 5 root 2 or any one of these answers. And the area is half times base times height. Half times root 50 times root 50. Root 50 times root 50 is 50. So half times 50 is 25. So that maximum area is 25 meters squared. So that's the answer to the question. Thank you for watching, and I appreciate all my viewers very much.